Okay, so I thought we'd do at least one more day of, oops, sorry, I didn't, there we go. I thought we'd do at least one more day of exercises. And so I was thinking about what to do this morning, and I thought about something I did for like a midterm review last semester, and not in the H section, but in the main section. And we built a Wordle cheater. A really quick word, or not a cheater, but a helper, right? So I want you to help me build a Wordle helper, not a cheater. To understand that, though, let's go ahead and first make sure that we understand the game. Remember that we are online, so if you have any questions, you can go ahead and post to the YouTube live stream here. I've got the New York Times edition up here. So Wordle is a game where it only works on 5-letter words, right? And so, I don't know, give me a 5-letter word. Sweat. Okay, let's go with sweat, right? Now that, oh, where's enter? Okay, there's enter, right? There we go. So now what that means is that S, W, E, and T, those letters do not appear in the solution. A appears in the solution, but not in that position, okay? It's in some other position. So with that in mind, as you said, irate, we know that that's not it because there's no T and there's no E. So give me another one. Audio. Say what? Audio. A, U. Why, did you already do this one today? Are they the same? Audio. All right, there we go. All right. That tells me that I is in the word and it's in the correct position. A is still in the word, but it's not there either. So therefore, we know that A must be here in the second position, the third position, or the final position here. Right? Media, nope, because the D is not in there. Help me out. Anybody? Usually you go with diagrams, diagrams like common letters that are together. C, H, I know. Share. C, H, A, I, R. There we go. Oh, no, R is not in there, is it? Oh, no, it is. I haven't guessed that yet. So, crossing my fingers here. Okay, so CH is not in there, but now we've put A in the correct position, right? Note here that we've also eliminated all these letters down here. So any other ideas? Blame. Oh, claim? C is not in there, though. Plain. Oh, spell it. Oh, plain? Is that what you said? Yeah. Okay, like the Great Plains. Plain. Enter. L is correct, though. Blame. B, L, A, I, M. M has not been eliminated. Enter. Oh, wait. That's not a word. Okay. Flare? Nope. F, L, B, L. Blaine, Blair. I'm not sure. Anybody? Flare? Sometimes it helps if like you could eliminate, guess a word that you know is wrong in order to eliminate a letter or something. All right, well, let's put that on hold over here. First of all, I'm going to remind you that today you've got your lab 3 due by midnight. Where should you be as far as assignment 1 goes? You should be well into it. The first and the second one certainly probably should be completely done by the end of the day. The third one, that gives you 2 more days to do the third one. Okay? I'll go ahead and get rid of this. Okay? So I'm envisioning here opening up a dictionary, an American dictionary, of course, right? Because it's English, right? And look at all letters that are only 5, or all words that are only 5 letters. Among those, I also want to say that, okay, well, also that A has to be in it. Also that, that the second letter has to be L, okay? So here I've got my American dictionary. Let's go ahead and write a Wordle cheater or Wordle helper, all right? So I'm going to touch Wordle.py. There we go. Help me out. What should be the first thing that I do? Probably load up the dictionary. Right? And at this point, we've done this a couple of times. We can almost breeze through it. But remember, I want to load up the dictionary, make sure that those end-line characters are not in there. But also, I don't want words like, for whatever reason, Elias or Elias in here. Right? I don't want aardvark, even though it's a regular word. I don't want it to, because it's not 5 characters. Right? Also, if I get a 5-letter word here that has a capital A, I don't want to have to worry about case sensitivity. So I want to make sure that they're all converted to, say, lowercase. We'll just work in lowercase exclusively. Right? So let's go ahead and load the dictionary, load words, right, from the dictionary. I will hard code that to be f is equal to fopen, or not fopen, but open, and it's in the current working directory here, American for reading. Right? I'm going to do this all in one line. I'm going to read all of the lines with one line. So lines is equal to f.readLines. There we go. And then I'm going to close it. That's the pattern that we've been following. Right? Again, there are a couple dozen there are a dozen different ways of processing a file. If you want to, you can take a look at a tutorial, and they recommend, open file as with blah blah blah, a whole bunch of other things that have different characteristics and like different error handling properties and stuff like that. This is good enough. Right? Now let's post-process this. I only want words that are 5 characters long, right? So first of all, let's strip out end-line characters. The way that we did that was words is equal to all words, W in lines, where, and I'll strip that, W line dot strip. There we go. For line in lines. There. That's going to give me all the words, and I'm not going to print it out because I think that there are like 400,000 or 300,000 words here. I'm not going to print them out. Okay. But let's do print out, say, a summary report that says, did you actually read those 300,000 lines of code, or lines of the dictionary? So print, in a formatted manner, read len of words lines. There. Is everything? Nope. This is not big enough for me sitting 2 feet in front of it. I need to get an updated prescription. But so I was going to ask, is it big enough for those in the back? It's not even big enough for me right here. There we go. That's a little bit better. Right. And now let's go ahead and call this function. Load words. Right. And Python, Wordle. Come on. There we go. Slow. 307,993. 307,993. Looks like it to me. Yay. Okay. Note here that there are some non-ASCII, extended ASCII characters. That's okay. We're never going to search for those anyway. Okay. You can filter them out if you want to. But they're all stripped. They all have their end-line characters stripped. Okay. The next thing I want to do is I want to winnow this down to only words that are 5 letters. So words is equal to word in for word in words. But I want to put on a conditional here. If the length of the word is 5. That should get us down from 300,000 here to something much smaller, right? Let's go ahead and try it. Only 13,000 5-letter words in the English language. Right? Okay. I want to also now change it so that words is equal to, is there a way to lowercase something? Does anybody know in Python? To lowercase? Dot lower, thank you. Word dot lower for word in words. There we go. And I'm going to read exactly the same number. 13,287 because I'm not changing the size of the set. I'm just modifying all the words. At this point, hey, I've got these 3 things. Why should I do this over and over again? Let's just go ahead and do this in one-liner. Well, I can go ahead and eliminate that last line by immediately doing it to lower. Right? How can I combine these two lines? Word dot strip lower. Careful there. Let's find out. Let's go ahead and try this. Remember, I should expect 13,287 words. Oops. What's wrong? For word in word, oh, words is not defined yet. For word in lines, there we go. That's not the mistake that I meant. There we go. 6,030. Okay, what am I actually getting there? Word in lines. So let me rename this to what it is. The line in lines, if the line is equal to 5 characters. H-E-L-L, end line character, not H-E-L-L-O. So if I'm going to do it this way, what do I need to modify this as? 6. And now I'm back up to that. I forget what the number was, but oops. If line in lines, I've got you right there. Oh, line. There we go. I renamed it. 13,287. My memory is terrible. Was that right? Okay. I guess I could just not be lazy and scroll up. 13,287. All right. Wonderful. I've got all the 5-letter words now. Stripped, all lowercase, etc. All right. Print them out. All right. Return. Let me go ahead and return this now. Return words. So that I can capture it here is equal to this. Let's just go ahead and, just as for sanity's sake, let's print out a sample. Like, let's go ahead and print the first 10 words. Dot, dot, dot. Right. Does anybody have a good one-liner, like, really quick way of doing it? I want it to be pretty, so let's go ahead and pprint it. And we'll import pprint. There we go. If I just did words, that's going to print out 13,000 or 12,000 lines, 13,000 lines. I don't want to do that. I just want the first 10 of them. 0 to 10. There we go. There. There's the first 10 of them. I'm doing a sublist here, starting at index 0 and going up to, but not including 10. Remember, it's inclusive, exclusive, like on most stuff. All right, I've got some good assurance here that I'm on the right track. I've got my 10 words here. Okay. All right. I want to make sure that L, A, and I are in the proper spots. So I could iterate through each word for word in words, right? And I could say that if word sub 1 is equal to, what was it? LAI, so L, and word of 2 is equal to A, and word of 3 is equal to LAI. There we go. Then I will print it out. pprint.pprint word. Okay. Let's see how many we have now. There we go. That's all correct, right? But we're still not down there yet. Well, let's come over here and say that, well, I know that Q is not in there. I know that F is not in there. For example, it's suggesting flare right there, but I know that F is not in there. So let's make another condition here. And how do I determine if something is not in there? I can treat it like a set or a list. I can treat strings just like a set or a list. And so I can say, and F is not in word. Now, it suggested flare before. So let's go ahead and see if it suggests it now. No. Right? I got rid of that one word. Okay. Continue writing code so that you exclude Q, Y, F, G, or sorry, these the blacked out ones. W, E, R, T, U, O, P, S, dot, dot, dot. Is there a better way of doing that? So let's go ahead and create a bunch of non-letters. We'd have to call them that something like, I don't know, excluded, there we go, excluded letters, right, is equal to, what are some of those excluded letters? W-E-R-T, U-O-P. W-E-R-T, U-O-P. Is that what I said? I don't want to have to keep going back and forth. U-O-P, W-Wort. Okay, good. Wordle. There we go. So let's go ahead and remove this, right, and do another condition here. If, or for, let's do this traditionally. Valid is equal to true, right? So for character in excluded letters, right, if C in, or for each is in the word, then valid is equal to false. So do you see what I'm doing there in a traditional way, in a traditional procedural style? For each excluded letter, if that excluded letter is in the word that we're currently considering, then it's not a valid word, like flare. F is in flare. So we would say false, and then we would not report it, right? And so outside here, if valid, then I'll print it. Do proper indentation there. So I excluded W-E-R-T, U-O-P. What else was there? S-D-H-C-N. S-D-H-C-N. There we go. And so what's something that should get that should exclude? Slain. Slain should now be excluded. There we go. And I'm down to 2 possibilities. Flail and Clake. Among those 2, oh wait, isn't F excluded?
No, F is included.
Oh, F is included?
Flair just had R, which was excluded.
Thank you. But I should not be excluding it though, should I? Oh, wait, did I screw up already?
No, Flair had the letter R, which is excluded.
Okay. I thought I was excluding F. Maybe I'm misremembering already. Anyway, so which one of those is probably most likely, like the one that you've probably heard of, flail, not, what the hell is Glake? Define Glake. A deception, a delusion, a trick, a transient gleam or glance, a fool or odd-mannered person. Good to know. We learned our word for the day. Glake. Go out there and call somebody a Glake. It's probably flail. Let's find out. Flail. Yay! I cheated and I won. All right. Good for me. Now, I don't think that it allows you to do more than one day on New York Times. That's okay. We've got Wordle Unlimited over here. Right? All right. So those are excluded letters. What about situations where I would need to include it? I just don't know where it is exactly. All right. So included letters is equal to. I'll leave that as an empty string initially. And that is an empty string because we're starting over here. But what I want is to do the same thing here, right? But for the included letters. So for C in included letters, if that were a letter that I expect to be in the word is not in the word, then I'm going to exclude that word as well. So I'm looking for everything that includes a letter, a letter that I'm excluding everything that includes a letter that should be excluded. I'm excluding anything that doesn't include a letter that should be included. Right? And then I'm doing a valid word here. I'm also going to take these things out, this thing out here. Reformat this. I don't know. I wonder what A style would do with this. It'll still work because everything is indented correct, I think. Python Wordle, yep. But it's kind of bad because this is double indentation. A style on Wordle. Okay. Oh, God. No. It totally donked it. All right. A style does not know anything about Python, does it? Python reformatter. Please, code beauty. Please fix my error. I should have backed it up before I did that. Python formatter format. Nope, because it's not valid Python. Wonderful. There we go. Actually, find 1, 2, 3, 4, and replace with 1, 2, 3, 4. 1, 2, 3, 4. Find and replace. How do I do replace? With only 1, 2, 3, 4. There we go. Replace all. There we go. Got that. Do it again. Do it again. No. Yeah, do it again. Do it again. Do it again. Okay, well, that gets me close enough. All right, there we go. Let's open that back up. There we go. Anybody know what block selection mode looks like in VS Code for? Oh yeah, I've got, okay. Oh, what is it? Right click and then scroll down?
Middle click.
Oh, middle click. I have no idea how to do that. There, I'll just fix this. Oh, come on. Good. Good. I don't know. Did anybody watch that video that I sent out on Python? Like, I said I don't have any Python videos except for this one, and it's the guy that is kind of criticizing Python a little, well, making fun of it a little bit. And he pulls out the ruler to see, is everything lined up correctly? All right, so do not do that again. Python Wordle. Okay. Oh, you'd better not have done that. Come on. Python Wordle. There we go. All right, so let's start over here. I mean, I could start with any of those. Should I start with Zesty? Probably should start with something that is most common. Give me a suggestion here. Smile. Enter. SM. Okay, E is at the end there. All right, so excluded letters would be SMIL. And then the last one would be E. Let's take care of that. Partial match. Right? So nothing, nothing, oops. Nothing, 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 and E. There we go. So that's my partial match. I can winnow this down even further. Let's actually see how far it winnows down like this automatically. I still have way too many, right? So I can winnow it down even further by saying that, restoring that logic that I had, that the last letter has to be E. Okay? So for C in partial match, right? If, I think I would do it like this, if C is not equal to my placeholder here, the hyphen, then I check. If word of, I'm going to have to do this index-based now. Word of whatever is not equal to C, then valid is equal to false. So do you see what I'm trying to do here? For each character in this partial match, right? Well, that's a hyphen, so I ignore it. That's a hyphen, I ignore it. That's a hyphen, I ignore it. Only when I get down to E, do I need to say that, well, if the word has that letter at that position, or does not have that letter at that position, then it's not a valid word. And so then don't report it. Okay? Except that I'm going to have to do this positionally. If for index in range of the length of partial match, I could, of course, hard code that to 5 instead. Now I've got that index. If the character, if partial match of index is not equal to the hyphen character, and now I can combine those two things. The word of index is not equal to C, then it's not a valid match. Right. There. So now I'm only going to get words that end in E. That's my intention here. Oops, sorry. Is it wrong? For index in partial match.
What is C?
You're right. What is C? C was set up here, so not C, but is not equal to partial match of index. That's what I wanted. That was a leave over of my first attempt, right? And that's why it didn't work. There. Now I'm only getting words that end in E. Just for reference here, let's go ahead and also keep a counter, or count plus equals 1. Set it equal to count is equal to 0. And then we'll report down at the end here, print formatted, count words remain. There. So that, oops, print F, there we go. Oh, we're down to 507. Okay. Well, instead of asking for suggestions, I'll just go ahead and grab one of these things that look good. Like, not fadge, whatever that is. Some of these sound so made up, but you know that they're right. Like some medieval, like cooey. What the hell is that? Canoe. That's a pretty common word. Canoe. All right, so C-A-N-O. Those are all excluded now. C-A-N-O. And we're down to 92 words. Right? Ooh, I like where, but W and H, they're not that common. So maybe we want to go for something a little bit more common here. Hedge. Hedge. Ah. D and G are now excluded. H and E are in it. So D, G, and H, what was it? E. Well, that's not going to help because it's just telling me that there are 2 E's in it. Right? So I'm going to leave that off because there might be a bug there. But we're definitely down to 13 words here. None of them were positional, right? Yeah, we still only know that E. He's, height, Phoebe. There, 3, and where those are the likely ones. So now let's go ahead and go with that where. W, H, E, R, E. Right. There's another dimension here that we do know that there's an H in there, but we know that it's not in the first position, and that's something that I'm not programming here that you could go ahead and do, right, to winnow it down even further. Where? Oh, okay. Where? Here. So W is now excluded, and we have almost a full match here. Blank here. There we go. That should take us down to nothing. 0 words remain. All right. Yay. Oh, thank you. Not an underscore. It's just me bad typing. We're down to one thing. What is it? Where? Were? There? There. Yay, another cheat. I imagine that if you had this cheater and if you put in that other dimension, you would never lose. Right? Play again. We've got 20 minutes left. We can play as many times as we want. Right? I've assigned this before as like a final exam. I think maybe a couple of years ago, there it was a little bit different. Instead of a cheater, it was here. What you need to process the dictionary and come up with all 5-letter words and then score them, right? So uncommon, like it was a way of trying to find the best first guesses. So for example, things with only one vowel in it, right? Then those are scored low. Things with duplicate characters were low because that gives you less of an opportunity to exclude letters. And I forget what it was that that I eventually came up with, but there's one with 3 vowels in it. Earth? There we go. We could try earth. Why would that be a good first guess? EA, the most common 2 vowels. R, T, 2 of the most common consonants. And H, a middling common consonant. Earth. Hey, almost there already. Right? So, blank, blank, blank. You know what? T is the last letter, or second to last letter there. T, blank. And excluded letters were E-A-T-H, earth. Darn it, what were they? R, A, and H, and we know that E is in there. R, A, and H. There we go. We're only down to 101, or 121. Flute. Okay, let's try it. Flute. Enter. Haha. And again, you could be pretty. You could probably actually check, inspect. Let's try one more. How do I restart it? Just refresh. All right, play again. There we go. We could probably inspect and then start going over this because I'm sure that the word is hidden somewhere in the code. All we have to do is find it. And then we could already, you could hack this pretty easily with JavaScript and just get all game theme managers, style. It's probably, let's see, where's the console? Not console, but Word. Okay, Wordle dot toString. Nope. Okay, Wordle. Let's go ahead and inspect what's in that object. All right, it's got a bundle. There's a countdown timer. Game row, game stats, game tile. Length. Oh, hey, T. There's a T in it. Game tile. No, I don't know. Anyway, you could very easily, reverse engineer it and then find where they're storing the solution because it's going to be in the JavaScript somewhere. And then you could very easily, hack it and get perfect scores. And then write your own bot and get perfect scores everywhere. This is how people do things. They, game cheating kind of stuff, and then they're found out, right? But what I wanted to do on Friday was come back to this idea of being able to look at what's going on in the background when you actually request something. I don't know if we'll be able to do that or if we're just going to go immediately over to Java or not. Depends. I don't want to get too far behind the other sections. So any questions on this? We do have plenty of time left here. So what I want to do here is maybe introduce you to an exercise that we're going to do in Java eventually, but instead let's do it in Python, so that we're introduced to the problem for Friday. Flail. All right, yep. All right. The rate of decay of a radioactive isotope is given in terms of its half-life. So if you've got like plutonium, it's radioactive. It gives off radiation. It's dangerous, right? Well, actually, it's okay to touch plutonium because I think it's alpha decay. Just don't swallow any, right? It can't. The alpha radiation can't break your skin, basically. But if it's inside you, then it can do all sorts of damage. There are other isotopes like strontium, I believe, does have gamma decay that is dangerous. This is a byproduct of nuclear weapons or nuclear fission. And it has a half-life of 28.9 years, meaning that if you start with 10 kilograms of strontium-90, right, 10 kilograms, then 28.9 years from now, it will have decayed through radiation, right, into 5 kilograms of strontium-90. Mass is preserved, so you still have 10 kilograms, but you also have 5 kilograms of uridium-90 and zirconium-90, which are isotopes that are decay products in it, right? So there ends your reminder of high school physics, right? There are these radioactive isotopes. There's a half-life. They decay. What we're going to do is we're going to write a program that takes as input the atomic number of the isotope that you're dealing with, the element name, the element symbol, the half-life in years. Not all half-lives are measured in years. Most half-lives, in fact, are measured in fractions of a fraction of a fraction of nanoseconds. Most of these things are very, very unstable, and they immediately decay. Some things are, billions of years of decay, like uranium-235, I think, what we use to actually get plutonium. And then you have an initial mass. Then what we're going to do is we're going to compute the rate of, not the rate of decay, but the actual decay. This is the remainder. Given a mass, how many years have passed, divided by the half-life, as the exponent to 1/2, gives you the remainder. So for example, after, in the first year, if you start out with 10 grams or 10 kilograms or whatever, you've got 10 grams of strontium-90 with atomic symbol or atomic number 38. After the first year, you're down to 9.76 grams. After the second year, you're down to 9.53 grams, ... After 29 years, you finally dipped down to half of the original, okay? In the last 15 minutes here, let's program that in Python. Those are some other options that I did, all right? Touch isotope .py, there we go. No fancy trickery here. No fancy, list comprehensions to get this done. Let's just go ahead and go with a straightforward implementation on this. Where's my isotope? There it is. Okay, let's get rid of these. All right. The first thing I want to do is read in command line arguments. Remember, I'm reading in these 5 arguments: the atomic number, the element name, and the element symbol. All right, there we go. Let's copy that over so that we remember what they are. First of all, how do I even start with command line arguments? I need a library to do that. That library is what? System. All right. Now I can check to see if I got the correct number of command line arguments. If the length of sys is not equal to these 5 things that I'm going to be reading from the user, plus the actual file name, isotope.py, if it's not equal to 6, then we will print f expected 5 inputs. I didn't get them, so I will go ahead and exit with an error code. I think you could just exit. Anybody? Yes? No? Yeah. Let's find out. Python isotope. Just 1. There we go. Uh-oh. sys.argv, I think it is. Okay. There. Expected 5 inputs. Otherwise, we've got those 5 inputs. Let's go ahead and get the first one. Atomic number is equal to... How do I convert that string into an integer? Int of sys.argv sub 0. Is that right? 0? What's the first argument? The script name. So I actually want 1 in this case. There we go. There's the atomic name, and I don't have to convert this at all. Atomic name, or the name, element name, excuse me, element name. I don't have to convert that to an integer. In fact, I don't have to convert that at all if I really don't want to. But dealing with variable names that are identifiable is way easier, right? And so I will do that for element symbol and element name. Symbol. Symbol being SR for like strontium, or hydrogen is H. Plutonium is what? is it PL? What isn't that iron? Pluma or something? PB is iron. There we go. Anyway, symbol. Make sure it's spelled correctly. Now half-life, that is going to be a double. So half-life is going to be a float of sys.arg v sub 4. And then finally m, an initial mass. Is m a good variable name, by the way? Was h a good variable name? Probably not. That's why I did half-life without thinking about it, right? Name you're not paying by the character. Name your things what they are. In fact, I'm going to rename this already to initial mass. Why? Because we're going to start out with some mass, and then it's going to be decaying into other mass. That I want a different variable for that. Mass is equal to initial mass, so that we can take it down, take it down, take it down. Okay? All right. Now that I've got all my values, let's go ahead and pretty print this kind of header right here. Okay, so a header is equal to a formatted string here. Can I do multi-line strings as a formatted string? Let's find out. So I'm going to replace strontium with a element name. I'm going to replace 38 with atomic number. I'm going to replace SR with atomic symbol. And let's see if that works. Print header. Oh, wait. Okay. 5 inputs. Atomic number would be 38. Element name would be strontium 90. Element symbol would be SR. Half-life is 28.9 years, if I recall correctly. And then the initial mass, say 10 kilograms. Come on. There we go. Did I misspell it? Element symbol, sorry, not atomic symbol. There we go. There we go. Hey, it worked. So do you see me combining two things here? By the way, the quote, 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 the 3 quotes, we talked about that before, that it's a multi-line string. Both Java and Python support that. That's a feature that many programming languages now support. But it's also formatted so that I can, just put those variable names right in there and get this header right here. Print header. Done. With 7 minutes left, help me with the rest of it. In the first year, we start out with that initial mass. And after the first year, it decays according to this formula right here. Right? So if I've got a formula, even if it's a simple one like this, what should that be telling you to do? Put it in a function. So let's put that into a function, right? Def, I'll call it decay, or decay. Why? Because that's what it's doing. It's taking a mass, it is taking a number of years that it decays, and then it's taking a half-life. Right? And the remainder, R, well, that's what R stands for over here, is going to be the mass times 0.5 raised to the power of y divided by h. Right? That's just me transcribing it, just me transcribing it. Now, let's convert that to actual Python. Mass times 0.5. Can I raise a power like that? Nope, that's bitwise OR. How can I raise a power in Python? Star, star, right? I'll go with that way because when in Python, do as the Pythoners do, right? And this is years divided by half-life. Now let's think about like Java or C where we've got potential integer truncation here, right? Are any of these integers? Who knows? They could be strings for all I care, for all I know, right? Make sure that put the, I don't know, order of operations here. PEMDAS would be, oops, yeah, I need those parentheses, right? Because E in PEMDAS is exponent to get done first, right? There, return remainder. Except that if it's a one-liner, don't bother doing that, just return. There. All right. What kind of a while loop are we going to want here to create this table? Oh, did I just say while loop? Okay. Spoiler, what kind of a loop, right? What's more natural? A while loop. Why? Because while the mass is greater than or equal to 0.5 times the initial mass. In other words, we still have some more to decay before it gets safe to use or handle or whatever. Right? Right? By the way, if you ever see anything that says drop and run away, that's the message that's put on a lot of radioactive isotopes that are used in applications. Drop it and run away, right? And then call somebody, I don't know, the IAEP or whatever they're called, International Atomic Energy, whatever. All right, so while we've still got too much mass, I need to decay it, right? So mass is going to be equal to decay the current mass by 1 year with the half-life specified. Right? That's our new mass, right? And let's print this out. Print in a formatted manner the year, formatted matter, the year that we're currently on, and then the number of grams that we have left as a mass, but I only want 2 decimals of accuracy there. Right? Okay. I need a year, right, is equal to, well, initially this is going to be like 1, right? There we go. And then I will increment it, year plus equals 1. And let's see if that works. Come on. Hey, got it on my first try. So year 1, we're down to 9.76 grams. 9.76 grams. 9.53, 9.31, it's rounding or something like that, right? And it took me 29 years to get down to half of what I originally had. Why? Because the half-life is 28.9. So it took you 30 years to get to the last one, right? This is after 1 year you have this much. After 29 years you have this much, right? Doesn't quite look exactly right. If you want to take care of that first one, it would be print formatted nothing, right? And then the mass, 0.2F grams. And now we'll get that first year, right? Year 0, we've got 10 grams and then dot. Right? So there is basically your first 2, or at least your first assignment right there, or your first exercise in your first assignment. It's basically just a plug and chug. Read input, properly format it, execute output. Right? Some other tips here. If you want to properly document everything, all non-trivial functions need to be documented, and you should do it the Pythonic way. Computes the remaining mass of a radioactive isotope after the given number of years, right? Based on the given half-life and initial mass. Right? And you can use markdown style stuff here. So this mass here, that's this variable here, that's this variable right here, and then that's this variable right here. If you were to actually like put this into some sort of an editor that understood markdown, it would mark these as code, right? It would have a monotype font there, right? Author above, right? So exercise 1, assignment 1, whatever, right? Author solves or produces a radioactive decay table based on a user's input. Don't get fancy. Don't write me an essay, right? Here's the author. Here's my email. Oops, we're not supposed to use CSE email anymore. At unl.edu, and then here's the date. And the only proper date format is ISO 8601 that you're working with right now, 0208. Done. All right. There is a pretty darn good submission if this were my assignment. Probably some things that could be improved. would be putting this into an actual main method if you want to, but it's just a simple script, who cares, right? But that would be going the extra mile, and we wouldn't take off points for that. Definitely need at least a header. If you decide to use any functions, they need to be documented, right? Use decent and good variable names, not cryptic single letter names, right? All the basic stuff that you should have picked up from CS1. Any questions? Because when we come back on Friday, we're going to do this again in Java. I'm going to start out with this code translated to Java, and then we're going to make it into an OOP style program.